And we're... Okay, good. All right, so we are working on this. We're working on two different ways to find the slope, okay? And what's another way of thinking about the slope? Okay, I'm hearing some really good things. Change in y in terms of change in x, okay, or delta y over delta x. That's one way that we always think about that. Or the derivative, right? So we're finding the derivative for these things. So there's two different ways. Let's start with this one on the left, okay? This is the first principle, as it's called, I guess. First principles. Okay, so if we have delta y, what is that? What is delta y? Change in y. So if we've got 2 points and we want to find delta y, like from here, from this point to this point, what is delta y going to be? Let's say this point here is x2, x1, and oh no, let's say this is x2 and y2, thank you. And this one is x1, y1. Okay? So what is... Right, so we've got for delta y what? Minus y1, 1, and over x2 minus x1. Right, good. So we can find our values for x2 and x1, but when we're approximating the tangent line at this point, what are we going to do at this point? What's happening to this point? Right, it gets closer and closer. Okay, so this point is getting closer and closer. Okay, so this point we don't actually know what it is. We kind of have to imagine a point that's getting closer and closer and getting so close to this first point, right? So we can rewrite this. We can rewrite this equation for a value of, so we've got a here and we can use x here, okay? We can use a there and x there. What will our value for y2 be? Okay, so this is our function y equals f of x, right? So here we have a value for x. What is our corresponding value for y? Y, okay. And y equals what? F of x, thank you. Yeah, y equals f of x. So y2 will be our f of x, okay? How about y1? What is our y1? Okay, so we have a here. So what is our corresponding f of a? Exactly. So we have f of x minus f of a. Okay? And that's going to be over what? We have, what is our value for x for this point? X, good. And our value for the other point? A, exactly. Perfect. So we've got f of x minus f of a over x minus a. Okay. So as q approaches p, that's this point here. As q approaches p, I'm going to write in those values here, or those names, q and p. As q approaches p, x approaches a. So x is getting closer and closer to a. And delta x is approaching 0. Why is delta x approaching 0? Right, exactly. Exactly right. So you're getting closer and those points are getting closer and closer together. And they're approaching the point where there's no difference. So the delta x, the amount of difference between those 2 points, the distance between those 2 points becomes 0. And our slope of PQ, which is our approximation line, right, from Q to P, dotted line, um, approaches our tangent line of P, right? So it gets closer and closer to being the right answer. So our tangent line is a limit as as delta x approaches 0 as of delta y over delta x. And we can simplify this, or we can fill in the blanks here, is the limit x approaches a so that's of f of x minus f of a over x minus a. That's an a. Okay, that's an a. All right. And any questions about that? Let's move on to the next way. Okay, there's one more thing we're going to look at today. Instead of a value for x here, we're going to work with a, and we're going to focus on kind of the difference between these values, okay? And we're going to call the difference h. So the difference between here and here is h. So what would this point be then? Right here. What would we call this x value? I heard it. A plus h. Yeah, a plus h. Good. A plus h. Okay. And what would be our corresponding y value here? F of a, right? F of a. Okay, so here we have f of a. And how about a corresponding f of a plus h? Okay, so I'll write that out here. We have a q point here, which has a plus h for our x value, and f of a plus h for a y value. Okay? So what would our delta y be? What would our delta y be? So the change in y value. Say that again? And how did you get that? Okay, yeah, good. So we have f of a plus h minus f of a. And on the bottom for our delta x, we would a plus h minus what? A. And of course you can see that those cancel out. A minus a is just h. So we're left with h in the denominator. So it acts a little bit differently, as you can see. As q approaches p, delta x approaches 0, h as well approaches 0. Okay, that space between those points gets smaller and smaller, and but we're still left with our tangent line being approximated by this secant line. Sorry. And this is a pretty important formula here. You'll see this a lot. Okay, so we can approximate our tangent line by writing the limit as delta x. Oh, sorry, that should be a delta x here as well. Delta x approaches a, and we have f a plus h. Sorry, yeah, you're right. The change of x approaches 0. Thank you. Change of x approaches 0, and over h. Okay. So there's these two methods to find the slope of a point using limits. Are there any questions about that? Okay. Good. So you can turn the page, take a look at the next page, Um, okay. And the record thing. Okay, good. So, um, why don't you try doing example 1 and example 2 on your own? Okay, so guys, let's take a look up here. We'll go through it together. I'm gonna put this back on the other side. Okay. Um, so what is our value for A? A equals -3. Good. Um, so what is our value for f of A? Does 15? And how did you find that? Right, yeah, you could go through the whole thing, but you're right, it is given as a point, so we have f of A. So we're going to rewrite this, limit as x approaches what? -3. Um, yeah, right here, yeah. So 15, okay? So this is your value for A, and this is your value for f of A, okay? So we have the limit as x approaches -3, and we want to put in all the blanks, right? So f of x we're going to replace with x squared minus 2x. And f of a we said was 15, so minus 15. And on the bottom we have x minus 3. Okay? And we're going to end up, those will both be plus. Okay? Pluses. And remember, you have to write the limit every time until you've substituted. So we can simplify some of this. We can write it as x squared minus, oh, we have that already. Okay. Okay, so let's factor that then. Right? So we have x plus 3 on the bottom, and we have x squared minus 2x minus 15 on the top. And if we wanted to factor that, what would we get? Okay, good. Yeah. X minus 5, x plus 3. Did you guys get up to this point on your own? Did you guys get up to this point on your own? Yeah, okay, good. And then we can cancel. So we'll put the invisibrackets in there. And we're left with limit as x approaches -3, x minus 5, right? So at this point, we can just plug in our value for x. So x is approaching -3, minus 3 minus 5 equals -8. So what is this value now? We have -8. What does that represent? Slope. Perfect, yeah. So this is our slope. This is our m value. What does the question ask you to do? Answer in general form, okay? Find the slope of the tangent, and then we want to find like the line of that slope, okay? And what is the equation that we use to there is a missing chapter. Y minus y1 equals m x minus x1. Okay, so now we can fill everything in. Y minus y1 is 15 equals -8. X minus 3, right? And if you simplify, well, you guys know how to do this, right? Yeah, okay. And we are left with 0 equals 8x plus y plus 9. Okay. Yeah, so maybe if you worked enough when you were working, if you worked enough while you were working on your own, you got to that. Are there any questions about that? No? Okay, let's try example 2. Example 2. So we're going to use the other method for this one. We have our f of x equals 3x plus 12. Okay? What is h? H is something that'll disappear because the limit is h as it approaches 0. So h is just another variable that we use when we use this method. You don't need to worry about it. It will kind of be around until you find your final answer. All right, so we have, this is our function here, and we're going to use the method of finding slope that looks like this. The second method as h approaches 0, and f a minus h minus f of a over h. All right, so limit as h approaches 0. What is our f of a? What is our f of a? What is our value for a? Yeah, 8. And what is our f of a? 6, right. So again, you can just take a look at the point we're given here. So 8 is our value for a, and 6 is our value for f of a. Okay. If you weren't given this, you could use our f of x to find a value for f of a. But we know that this will be 6. How about we want to get everything out there. So what is our f of a minus h going to be? So we do need to use a function, right? So we have our square root of 3. And what are we going to put in here? What are we going to put in the brackets? So we're going to put a minus h, and we know what a is. It's 8, right? So we're going to say 8 minus h plus 12. Minus, and we said our value for f of a was 6, right? Minus 6. Sorry? H will approach 0. H will approach 0. F of a plus h, thank you. F of a plus h. Thank you, yeah. We've got two different variables. We've got the a and we've got the h. So they're two different things. 8, a is 8. So a is 8 here, okay? So remember, okay, let's just take a look at this page again. So this h represents the difference between our first point and our second point, right? So that's why this h is approaching 0, because it's getting smaller and smaller and smaller, okay? All right. So next we can just kind of simplify everything. Limit as h approaches 0. So we're going to make this 24 plus 3h plus 12 minus 6 over h. Okay, so we just did distributive law to distribute that 3. Next we've got the limit as h approaches 0 of 36 plus 3h minus 6 over h. Okay. And what can we do to get rid of our radicals there? Sorry? Yeah, conjugate binomial or conjugate pair, right? So we can multiply both sides. I can't extend the page further this way. We want to multiply both sides by, or the top and the bottom, by square root 36 plus 3h. It's so not enough room. Plus 6, okay, plus 6 over square root 36 plus 3h plus 6, okay? Sorry, there's really not enough room there. Yeah, I'm left-handed. Did you really? I was gonna say that's impressive. Um, minus 36, thank you. Minus 36. And what are we gonna have on the bottom? H times, yeah, this big thing. 36 plus 3h plus 6. Okay. And then we can continue as h approaches 0. So we're left, right, these 36s cancel. We're left with 3h on the top. And on the bottom, we've got the same thing, right? So we've got h, 36 plus 3h plus 6, right? And what can you cancel here? H's, right? So you can cancel the h's. Extend the page. And what we're left with, keep going, limit as h approaches 0, 3 over 36 plus 3h plus 6. And then from now on, from this point on, you can plug in your value for h to evaluate. So we're going to substitute in our value for h as h approaches 0. Because now that we've gotten rid of this h, it won't just cancel on the bottom. So at this point, if we put in h, we would get 0 on the bottom and 0 on the top, right? So we know that we have to keep going a bit. And then at this point, if we put 0 in, what are we going to get? So, right. So square root of 36 on the bottom, we're going to get 3 over 6 plus 6 equals 3 over 12 equals 1/4. Okay. So that's our slope. Yeah? Yeah. Exactly, yeah. So in this case, h always approaches 0. H always approaches 0 because, yeah, once again, it's that difference between those two. Yeah. So our value of a, we just took it right from the point that we were given. So we want to find it at this point, right? So we're told, it moved over a bit, but we were told that we're trying to find the slope at this point. And our value of a will always be that x value there. Yeah. Yeah. Okay.